In this video, we're talking about how to use the zero theorem to find solutions to a quadratic equation. Remember that the zero theorem tells us that if we have an equation where we have p and q multiplied together, and p times q is equal to 0, then either p has to be equal to 0 and or q has to be equal to 0. And that should make sense to us because if we know that p times q is equal to 0, then the only way for this equation to be true is if either p is equal to 0, because then we would have 0 times q equals 0, or just 0 equals 0, so that would be true. Or if q were equal to 0, because then we would have 0p is equal to 0, or just 0 equals 0. So in other words, when we have two things multiplied together, and the product of those is equal to 0, then we know that one or both of them has to be equal to 0. And we can use this zero theorem to find the solutions to quadratic equations. So let's look at our first example here. We have x squared minus 3x minus 18 is equal to 0. This is just a standard factorable trinomial. So we want to go ahead and factor this. And when we do, we're going to get x minus 6 times x plus 3 is equal to 0. If we multiply that back out to check ourselves, we get x times x is x squared, and then we get plus 3x minus 6x would be minus 3x, and then negative 6 times a positive 3 gives us a negative 18. So we factored that correctly, and now all we're saying here is that if we have this factor of p multiplied by this factor of q here, then in our new equation, we can basically say that this factor is like p, and that this factor is like q. So we have basically p times q is equal to 0, and that tells us that one or both of these factors has to be equal to 0. So what we'll do is break each of them into their own equation. So we'll say x minus 6 is equal to 0, and or x plus 3 is equal to 0. Adding 6 to both sides here, we get x is equal to positive 6. Subtracting 3 from both sides here, we get x is equal to negative 3. In other words, the solutions to this quadratic equation are x equals 6 and x equals negative 3. If we want to double check ourselves, we can plug either of these solutions one at a time into this factored equation here, or into the original equation, and we should get 0 equals 0. You can see that briefly here. If we plugged in x equals 6, in this first factor here, we'd get 6 minus 6, or just 0. So we'd have 0 times this factor of x plus 3, but of course anything times 0 is equal to 0, so we'd get 0 equals 0. Same thing here, x equals negative 3. If we plugged that in, this factor right here would be negative 3 plus 3, which would be 0. So we'd have 0 times a factor of x minus 6, and because anything times 0 is still 0, we'd end up with 0 equals 0. So we can always double check ourselves that way if we want to. Let's look at a second example here. We want to make sure we have all of our terms together on one side with the right hand side equal to 0. So we'll go ahead and add 4x squared to both sides, and that'll give us 4x squared minus 25 is equal to 0. And now, in order to factor the left-hand side, what we need to recognize is that we have the difference of two perfect squares. 4 is the perfect square of 2, x squared is the perfect square of x, and 25 is the perfect square of 5. So 4x squared is a perfect square, and 25 is a perfect square. And remember, when we factor the difference of two perfect squares, we just take the square root of each one. So the square root of 4x squared is 2x, so we go ahead and put those in. And the square root of 25 is 5, so we go ahead and put those in. And then we make one of the factors plus and one of the factors minus. So we'll go ahead and say equals 0. And now we have two equations that we can set equal to 0 individually. So we'll say 2x plus 5 equals 0, and 2x minus 5 equals 0. In this first equation, we'll go ahead and subtract 5 from both sides and get 2x equals negative 5. Dividing both sides by 2, we'll get x is equal to negative 5 halves. In our second equation, we'll add 5 to both sides and get 2x equals positive 5. Divide both sides by 2 and get x is equal to positive 5 halves. So the solutions to this equation are x equals negative 5 halves and x equals positive 5 halves. Looking at our final example here, we have 3x squared minus 6x minus 9 equals 0. And even though this is just a standard trinomial like our first example, we need to realize that we have a common factor of 3. In other words, we can factor a 3 out of each one of these terms, and we want to go ahead and do that. Dividing every term in this equation, both the left and the right hand side, by 3, we'll get 3x squared over 3 will just give us x squared. We'll get negative 6x over 3 will give us negative 2x. And we'll get negative 9 over 3, which will just give us negative 3. 0 over 3 is still 0. So we still haven't changed the equation at all. We've just divided through by a constant, which we can do. And now we can go ahead and try to factor the left-hand side here. So when we do that, we'll get x minus 3 times x plus 1. And if we want to double check ourselves, we can see we get x squared plus 1x minus 3x would be a minus 2x. And then a negative 3 times a positive 1 does in fact give us a negative 3. So these are going to be our factors, and we'll just set up our equations as x minus 3 equals 0 and x plus 1 equals 0. And then solving both of them, we'll get x equals 3 and x equals negative 1. So what that tells us is that x equals 3 and x equals negative 1 are the solutions to this quadratic equation, and that's how you use the zero theorem to find solutions to quadratic equations.